Hello class, this is Math 1440, section 8.8, which talks about average value. So here is our question. Find the average value of the function. Let's see, where am I? Sorry. Okay, yeah, so here's our function. F of x comma y is equal to 6x squared y cubed over the region, which is a plane, just the xy plane. The region's always in the xy plane. And we'll call that region R. And here is how we define R, where R is equal to the set of all ordered pairs x comma y such that 0 is less than or equal to x, which is less than or equal to 2, and also y is greater than or equal to 0 and less than or equal to 3. So the tip is to always sketch the region R. So that's what we're going to do next for our solution. So for the solution, here's a quick sketch of R. It's just going to be a rectangle 2 by 3 because x goes from 0 to 2. So on the x-axis we go 0 to 2, and on the y-axis we go from 0 to 3. We get that rectangle which I labeled R. So that is our region R. And we're going to have to know what the area of the region is because that's going to be part of our formula for average value. So area of R is simply 2 times 3 because the area of a rectangle is length times width. And of course 2 times 3 is 6. So note, R is a rectangle, 2 by 3. And here's a nice little fact. The order of integration never matters when your region is a rectangle. So the order of the integration does not matter. You'll see what I'm talking about later if you're a little confused now. But if your region's not a rectangle, then you got to be careful about your order of integration, how you set things up. So here's the formula. So the average value of f, which you can just call f average, is equal to the double integral over your region R of your function f of xy with respect to area divided by the area of R. Let me drop back so you can see that better. So f average is equal to the double integral of your function with respect to area over the area of R. Okay, so now let's do this double integral. So notice I chose to make my outer integral in terms of x. So x equals 0 to x equals 2, and then my inner integral is y equals 0 to y equals 3. I could have flip-flopped those integrals and gotten the same final answer. The work would be different, but the final answer would be exactly the same. So I just randomly chose x to be my outer integral and the y's to be my inner integral. Here's our f of x comma y, and you must write dy first and then dx, because my inside integral is y, so you want dy first. The outside integral is x, so you want dx last. Now, had I switched those integrals, putting y on the outside and x on the inside, then I would have switched this to dx dy. And then don't forget to write over 6, because that was the area of our region R. So our f average, we said, was equal to this formula here, and then which is now going to be equal to this with the numbers we were given. Okay, and then to evaluate this, let's make life a little simpler. Sorry, this is getting blurry. I'm not sure why. Okay, here we go. So here's what I'm going to do next. You're allowed to pull out constant factors all the way out over here. And then this dividing by 6, this is a constant. I'm going to pull that out as times 1/6. Isn't dividing by 6 the same thing as multiplying by 1/6? So I pulled out the 6, and dividing by 6, I called that times 1/6. So I pulled both of those constants out. And now what I'm doing is, okay, so I did that, and now I'm just rewriting what I have. The integral from x equals 0 to 2, and then that y equals 0 to 3. And now I got rid of these numbers here because I pulled them out. And then to evaluate a double integral is easier if you do the inner one separately. You always do the inner one first. So I'm going to do this inner integral. When I get my answer, I'll input it for the outer integral. And here's something nice. Doesn't 6 times 1/6 equal 1? So these drop out. These cancel out. So you don't need that anymore, a number in front, because 1 times anything is that anything. So these cancel out. I should go boom, they cancel out. Okay, so now let's see what we have. We're doing the inner integral first, which is right there. The inner integral is the integral from y equals 0 to 3 of x squared y cubed dy. Remember, we're integrating with respect to y, so any x factors are constants. You can pull this x squared if you want on the outside, or what I did, I just wrote my answer as, I just kept the x squared, and then the integral of y cubed dy is y to the 4th over 4 by the power rule for integration. So remember, whenever you have a constant factor, you can pull that out as part of my answer. So it's going to be x squared times y to the 4th over 4. And then we're going to evaluate this expression from y equals 0 to y equals 3. You always begin with the upper limit first. So input the 3 wherever you see a y. So that's what I did. Isn't 3 to the 4th 81? 81 times x squared. I wrote that as 81x squared over the 4 minus, and then when I input y is 0, this whole expression goes to 0. So when I subtract those quantities, I just get 81x squared over 4. That is my answer to the inner integral. And now all we got to do is the outer integral where we input that answer. So for my final answer, go to the outer integral, which is in terms of x, input that answer. And if you want, you can pull out the 81 fourths, or you can just say the answer is going to be 81 fourths times, and then the integral of x squared dx is x cubed over 3. That's a 3 there on the bottom. And then 81 over 3, if you divide them each by 3, you get 27 over 1. So this really reads, it's kind of hard to read maybe, it originally was 81 fourths times x cubed over 3 by the power rule of integration for x. And then 81 over 3 reduces to 27 over 1. Okay, and now you input x equals 2, wherever you see x's. So pulling out the 27 fourths, I'm going to get 2q, I pulled out the 27 fourths, and now we're just going to have times x cubed from 0 to 2. And with the 27 fourths pulled out, you're going to get 2 cubed is 8, minus, and 0 cubed is 0. So it's going to be 27 fourths times the expression 8 minus 0, which is 27 fourths times 8, but 8 over 4 reduces to 2 over 1. So our final answer is 27 times 2 is 54. So that's our final answer. That is the average value. So we are done. So backtracking for a second, you didn't have to you didn't have to pull out the 27 fourths entirely. Some people like to just go 27 at this point here. Some people like this to write 27 fourths times 8 minus 27 fourths times 0. This is the same thing right over here. So whatever your style you like better, that's fine. Okay, so to conclude, let me just drop back so you can see the whole problem in case you want to hit pause and write anything down. Let's see if we can get this in focus here. It takes a while. It does not want to get focused.
Oh, yeah.
That's okay. I'm going to tap the screen and see if that helps. Yes, that did help immensely. Okay, so there is the final problem, all in one shot. All right, hope this was helpful, and this is our last section for this week. So I know today's only Tuesday, but you get Wednesday, Thursday, and Friday to finish up these two sections that we're supposed to cover this week, 8.7 and 8.8. You can see Learn for the lecture notes for those two sections. So we're done with the notes and the videos for this week. So work hard on that web assign, and hope everyone's doing well. Bye-bye.